So, hey guys, this is Hemant. So today we are going to solve GFG's problem of the day, which is very famous. So without further ado, let's start with the problem. So the problem states that subarray range with a given sum. So those who already have solved similar problems like using hashing, right? You need to find the ranges, the subarrays that contains the given particular sum and count all the subarrays that given sum. This is very similar to it, and in fact this is almost the same thing. So they will be given an unsorted ar- array, and then they will give a target, and your goal is to find all the subarrays which contains this particular target. So without further ado, we'll just see this particular example. So here the array is 10, 2, -2, -20 and 10, and the target is -10. So how are we getting output 3? So we can see there are three subarrays, which is 10, 2, -2 and -20, which gives us -10, and then there is 2, -2, -20 and 10, which gives -10 again, and then -20 and 10, which gives -10 again. So there are whole together three subarrays which gives our given target. So the total count of these subarrays are 3. So hence the answer is 3. And there is one more example. So this is very simple. 23 plus 10, 33. Only this one subarray contains. So they did not say, kind of, there is a guaranteed subarray, at least one subarray of the given target. So they did not mention any kind of such thing. So we need to, kind of take care of that situation as well. If there is none, you need to return 0. So expected time complexity is O of n. We need to do it in a linear iteration in one pass, and you can use a space of linear space. So how are we going to solve this problem? See, the brute force is that you take all the subarrays and compute the sum of those particular subarrays and match it with the given target. If it matches with the given target, and you can just increment the subarray count which has this target as +1. So if you do that, we'll end up with n square complexity, because we are generating kind of all subarray. First this one, and then this, and later we're gonna go this, we're gonna go like this, and then so on and so forth. So which gives n square complexity. You can see the size, the constraints are 10 power 6, and we cannot afford n square complexity, which gives us a TLE. So one way to solve this problem is through hashing. So those who haven't kind of solved problems similar to this, I suggest them to solve kind of 2 sum, 3 sum, and then there is problems which kind of relies on hashing, very basic problems, and then you can solve a binary sum as well. You can follow kind of there are a lot of YouTubers, you can follow their content, and once you're comfortable with these particular easy problems, and these problems will be this particular problem will be very easy. So without a further ado, although we did not discuss any edge case, there is no certain edge case. There is only one certain edge case where there might not be any subarray that containing the given target, so you need to return 0. So we need not to handle it separately. We initialize our answer with 0. So if we did not find any particular subarray which contains that particular target, we just directly return the answer which contains 0. So there is yeah, I will start with this particular thing. So basically the given array and the target, we're gonna use a hash map like I said before. And why am I putting so this is a key pair value, this is a key and its value. You can ask me why I'm initially putting 0 comma 1 in the map. See, I'm putting 0 comma 1 in the map because there is a subarray with the sum 0 and it's occurring 1. So this is the sum and this is the occurrence. This is how we are going to store in our map. This is how we are exactly going to store in our map the sum and its occurrences, how many times the sum is occurring in throughout the subarrays. So that's how it is. So there is a zero sum. There is, initially we are starting with sum 0, right? So it is occurring at least once. So that's very important. And this is also important because if, let's say, our target is designed such a way that at some point you will hit 0, and that 0 will also compromise to a subarray which gives our target. So if there is none existing before, which is at least one occurrence, you might end up with a wrong answer, or less count in the given count. So that's the whole issue. So that's why we are initially putting our zero sum at least occurring at once. So initially the sum is 0, and then we can iterate throughout the array. We're only iterating array at once, so that's why it's a linear complexity approach. So yeah, we'll start. So initially we're taking the 10, so sum is 10. We see if how we are going to use hash map very effectively is that it's simple basic math, that if you want to target, right, whatever the your previously visiting elements, if you subtract and see with the current sum, if it is existing, then if you add that particular elements, then that will give you the target, right? So basically I'm saying, let's just say if x plus y is z, I'm concerned about this z. Okay, in order to get this particular z, all I need to do is, if there are two variables, okay, if the current variable is y, if I just store, see if y, if I bring this side, if I just see if z minus y, if I just see current element, okay, if given z, and if I subtract with that, if I see if there is existing x, so it's very simple that all I need to do is add that particular x, sorry, all I need to do is add particular y which gives us the z. So this is the basic simple math. So that's why I'm just seeing if there is any such thing, any sum by targeting, by minusing given target, if I'm getting any particular occurrences in the map. If there is any occurrence, I'm just seeing if the sum is 10 and the target is minus 10. 10 minus of minus 10 is 20, so there is no such occurrences. So what we're doing is it's false. So I need to put this particular sum with occurrence 1. So 10 with 1. Why this is useful? Because we never know what future elements are, and with that elements, if the target comes to end up with a 10, then we can say that adding all those elements including this 10 is one subarray, which is count of 1, which gives this particular target. So that's the way to solve this particular problem. Very easy problem. So we'll move on further. Now the sum is, initially it was 10, so we are going with 2, so it's 12. We're seeing if 12 minus of minus 10, which is 22, if it's present in the map. So unfortunately it's not present in the map, so we're putting 12 comma 1 in the map, and we are continuing further. So here you can see it's a very interesting case here. Now again it's minus 2, 12 minus 2 is 10. We're seeing if at all 10 minus 10, which is minus 20, plus 20, it's not present in the map. So see, we are updating its count in the future. If there are elements that will end up making 10, so with adding with that elements including 10 is 2 subarrays, which gives us the target. So that's the whole point. So sum is 10, so it was 10, so I just incremented 10 was occurring twice, and then the sum is, initially we have done process so far is 10. So again we are going to minus 20. 10 minus 20 is minus 10. So now you can see this is the target, right? Isn't it? This is the target. So how are we going to get the target? We need to see if there is any existing, the way we discussed x plus y z. If minus 10 of minus 10 is 10 minus 10 plus 10, which gives us 0. So see, that is why we inserted, At some point we don't know, we'll end up with a 0 sum and it's occurring once. So initially answer was 0, so we know that now, yeah, it's present, 0 is present. How many times it's present? It's just present once, so we are incrementing our answer with 1. And the sum was minus 10, so again we end up with 10. So minus 10, we are just minus 10 plus 10 is 0. Now again we are seeing if sum minus the target, which is 0 minus of minus 10, which is 10, is it present? Yeah, it's present. How many times it's present? It's present 2 particular times. So that is why I'm saying adding up all the elements to this particular. See, so the basic idea of using map is how many times this particular sum, right, this particular sum is contributing to the whole subarrays. So it's contributing 2 times. How 2 times? We'll just see. So initially we can see here, we can see here, so 10 was contributing in this particular subarray once, again it was contributing here twice, again here thrice. So that's why it's very important. So 10 was occurring twice, so we incremented our answer and we are getting this particular answer, which is the given answer. The whole idea of this particular problem is you just need to construct this basic, x plus y is z. If you want z and you have the current y, you need to see if you can find previously x. If it is previously found, then that is how you're going to get the answer. So without a further ado, let's just implement this problem. Let's just close this. So basically we need the answer, and also we need current sum to populate. We need a map like we discussed earlier to store the sum and its frequencies, how many times it's occurring throughout. In the end we need to return the answer. So let's just implement what we have dry run together. So we need to traverse all the elements in the array. The first thing is we need to check if at all there is, we need to actually update our sum as well, and then we need to check if map contains this particular sum minus star, right, target. If it contains, all we need to do is get how many times it's containing, and later we just push the current sum with incrementing current sums frequency count. I think this is all pretty much there is left to do. We'll just run and see if we are getting the correct answer or not. Okay, what are we doing wrong? So okay, see, this is where I made mistake. I discussed with you guys and I myself, somehow this happened because see, I did not insert a zero sum, okay, with occurring 1. So this is very crucial because we are losing one count because we encountered zero sum array, right? It was occurring once, so that's the whole thing. Let's just run this and see if it's working for all the test cases. So you can see it's actually working for all test cases. So yep, thank you. We'll see you in the next video.